Today's tricky topic in 2 minutes has to do with average speed and average velocity. So, the first story I'm going to tell you about has to do with your race against Usain Bolt. You know, he's one of the fastest people on earth, and he's challenged you to one lap around a track. So, the good news is that you get to sort of pick the terms of the contest, and you say, okay, we're going to have an average velocity contest around the track. So, hopefully he'll agree to that, and then off you go. So you run around the track, he runs around the track. Both of you get around the track. Of course, he gets around a lot sooner than you do. That's my cat up there. Yeah. He gets around the track a lot sooner than you do, but when the end of the race comes and you're standing at the finish line, which was also the starting line, and he's standing at the finish line, which is also the starting line, guess who wins? Well, if it's average velocity, it's a tie because both of you have the same displacement. That is, both of you went from starting position to the same final position, and then because you did that, there's no actual displacement, no change in position for either one of you over the contest. So it doesn't really matter that he got there a lot faster. The average velocity contest is a tie, and as long as you all go the same distance, excuse me, not the same distance, but you have the same displacement, that's the way that's going to end up. So here's a second story about average velocity and average speed. So there's a river you have to cross, right? And let's say it's a mile across, and you have a choice of how fast you're going to swim across the river, or actually take a boat across the river, let's say. So it's a mile across. So you're going to race across the river, a mile over and a mile back, okay? So one person can go 1 mile an hour and does it the whole time, 1 mile an hour over and 1 mile an hour back, right? So that's 2 miles, and it's done at 1 mile an hour each way, right? So it's going to take 2 hours for sure, right? So if there's another person who goes twice as fast on the way back, but only half as fast on the way over, right? Do they win or lose this contest, right? If somebody goes half a mile an hour over, right, but twice as fast, 2 miles an hour coming back, do they win or lose? So the way you do this problem is you have to look at the total distance and the total time for each part. So in this case, to go 1 mile at half a mile an hour, that would take you 2 hours, right? And then on the way back, that would only take you half an hour because you're going to go 1 mile, but you're going to do it at 2 miles an hour. That only take half an hour. So the person who goes half speed on the way over and then twice the speed on the way back is going to take a longer time to finish the race than somebody that just goes at a constant 1 mile an hour over and a 1 mile an hour back. So the person who does half speed over and twice as fast coming back takes them 2.5 hours to do the trip, whereas the other person who just goes at 1 mile an hour each way, it only takes them 2 hours to do the trip. So that's a little bit about average speed and average velocity.